Hi, I'm Dale Doherty. I'm here at Food Camp, and I'm going to have a conversation here with Sridhar Vembu of Zoho. And I just came from his session, which was entitled Alternatives to College. And in some of the things we've been covering on our radar about Education 2.0, I think there's some really interesting lessons here about a new model that Sridhar and his company have used in India to train young people out of high school how to program and how to work in their company. So welcome today, and thanks again for being here.
Happy to be here.
Yeah. So tell us how this got started.
So this actually comes from, our company got started in 1995. So, and as a company, young company without any financial backing, it's really hard to hire people in India. And typically in India, the talent wants to work for famous companies, brand name companies, the Microsoft or Google India or any of the large companies, or the Indian companies like Infosys or TCS, all of them. So for a small company, it's always hard to find people. So we actually decided to do some unusual experiments, and it started with actually my brother, who was running the India Development Center. He was the one who created it, my brother Kumar. He hired my last brother, Bunny, who actually didn't do that well in college. He actually wasn't a very good student, and he wasn't in engineering. And Kumar just hired him and trained him in C programming. That was not something that I expected to be a successful experiment, but Money proved us wrong, actually. He did
now,
so well.
you had gone through the elite engineering school yourself, and then you went to Princeton.
Yes.
And then began to work in the US.
That was my background. My background was I went to IIT Madras, an elite school, and then I came to Princeton, and I got my PhD in electrical engineering. And based on all that, I would not have expected that someone just could be trained in programming and they would do well.
Right.
And that's what my brother Kumar proved with my last brother Money.
Right.
So, and that set the tone of the company, and he started hiring people like this and would train them more and more, and he had a really good training program himself. For a lot, the biggest contribution he made was he personally trained maybe the first 100 or 200 employees by himself. And that set a foundation for our culture, which continues to this day. And by about 2004, I ended up inheriting the development center, and I wanted to formalize this program. And I asked myself, what could we do better in this? And I decided, when I looked at our stats of our employee performance, I found that there wasn't any correlation between their academic background, which college they came from, how well they did in school, and how they were doing in the workplace. So there was not much of a correlation between the two. Then I asked myself, could we then go back and just hire them straight out of high school and put them through a similar training program, maybe more intensive, and still have them succeed as employees? So I decided to start a small project on this. The first thing I did was actually recruit a faculty member from one of the engineering colleges. And he came from an unusual background. He actually had a math background, and he had taught himself programming, and he was teaching computer science.
So, but he wasn't trained in computer science. He was self-taught himself.
Yeah, he was self-taught from math. It's not a big leap, but he still, he had made that mental leap himself to move from math to computer science. So when I explained this concept to him and he jumped at the opportunity, he said, I would love to do this. Then he came on board, and this was in 2005. And the first job he had was to actually find students. And if you go around telling this concept to like middle class Indian families, when you say middle class in India, that would be maybe the top 10, 15% of the population. I mean, 80% of the population is actually, poor by any global standard. And he said, we cannot really go to the middle class schools. They will not come. The parents would not want to send. So let's go to the neighborhood schools that are, where the kids have a real need, and we'll test them. And if we find suitable kids, we'll take them in our program.
So poor kids from not very good schools.
Yes, that's what we started doing. And these kids, what we found, they came into the program, and now we had to create a suitable curriculum. What do we do with them? I mean, this was the first challenge. And here is where our professor got really creative. I mean, we both discussed this problem a lot. What do we do with the students now that we have 6 students? And then we said, let's dispense with traditional computer science curriculum. That's not going to cut it here because it's too complicated, too theoretical, too abstract. Let's focus on, let's ask a question. If I'm a 15-year-old and I want to teach myself programming, what do I do? I'll hit the web, I'll hit Google, and I'll search for it. At that time, the popular language would be, PHP, HTML and PHP.
Right. So you're focusing on those as the basic building blocks.
Exactly, building blocks. So then we basically download this tutorial material and start teaching the kids on this. And we had a fairly rigorous program. They would spend maybe 2 to 3 hours in basically a kind of a classroom setting where they are guided basically on all the basic stuff. And then afternoons would be their own assignments. They would start with the most simplest hello world type of assignment, and they'd progressively build more and more complicated websites, really, web apps. Then we would extend from the HTML to the PHP, and then with a backend database, MySQL, just the way web apps are built. And this is what they started learning. And after about the initial period when we were figuring all this out, within about 2 months, these kids started really doing well. They were actually motivated, passionate. You have to see it. They come in at 9 a.m., they're there. The faculty would leave by around 6, but the kids will be there, because they have nothing to do. So they have, 3-4 more hours they'll spend. It's of course a nice air-conditioned office, very comfortable, and they love all this. And they have all the toys to play with. So they'd be there 12, 13, 14 hours. They would come in on Saturdays, sometimes even Sundays. And they are learning all the time. And the classroom instruction only turned out to be maybe 2 or 3 hours a day, but the remaining time they are spending among each other, peer-to-peer learning.
And they're doing stuff.
They're doing stuff.
Right.
And so on.
Right.
They're programming. And then they go to the web and they see stuff. I want to build something like this. I want to build that cool little calendar widget. I want to build that kind of a site.
Right.
So they start giving themselves assignment. I want to build this library.
Right. Now, you also said that they speak Tamil rather than English, and so you had to figure out some of that.
So what we had to do is generally in our company the working language is English because we address a global audience, but still most of these kids we had to figure out how to teach in both, Tamil as a medium spoken instruction, but the software that start is in English, and all the manuals, all the tutorials are in English, because there's hardly any technical literature that's translated into Tamil. Simply because India is so, all the middle class Indians are so well versed in English, nobody bothers to translate all this material. And it would be too hard too, because anyway all the words would be in English. You don't have an equivalent word for a lot of the concepts, things like website. There is a Tamil word, but it's just too hard.
So there's an initial ramp up that's a little difficult.
Right? But once we figured that out, these kids, within about 6 months, we knew this is going to be really successful. The kids are doing really well. Then we said, we'll take another batch of students and overlap with this batch. So that what we wanted to do was, the first batch itself becomes a kind of a peer group that motivates, gives sort of peer-to-peer help on doing this.
Right. So they're turning around and teaching what they just learned.
What they just learned, helping they become kind of a teaching assistants to their faculty. So this program actually, typically we keep a student for about 9 to 12 months in our program. And by the time they reach 6 months, another batch enters. So the remaining 3 to 6 months, they are spending with also the next generation. They are learning more complex stuff. They are also actually helping out the next generation for the faculty. That's how the program works. And then once the 9 to 12 month period is over, they join one of our various product teams. In Zoho, we have, in the company, about 60 plus product teams, doing a variety of products, everything from online word processor to presentation to CRM systems. So they would typically join one of the teams.
And this is like at 17?
They are, now they would be 18.
18?
Yeah,
okay.
They would be about 18 because they've spent a year in it. And they join as really apprentice, like sort of an engineer apprentice trainee. And this period lasts about a year. And I want to mention, we pay them during the entire time. So from the day they join, we start paying. And then when they become apprenticeship.
Why is that necessary to pay a stipend?
particularly we want to take the money equation out of the picture for a lot of these kids, because a lot of them are not going to college because of economic reasons, and they have family compulsions to go to work. So we want to take that out. If you pay them, then they can stay focused on this program, and they don't have to worry about the family stress of financial stress on this. That's why we decided that it's worth paying.
Right.
And when they join and they become apprentices in a team, the pay goes up, and then which they spend maybe about a year. That again varies depending on the particular team leads and then on what their assessment is of the progress they made, and then they become regular employees. Typically within about a 2-year, maybe maximum 2.5, before that they would become regular employees. And at that point they just, like any other employee for us. And some of them may choose after that, typically 3-year period, may choose to continue like an evening school or or an online school type of a thing, but it's up to them. We don't actually have any particular pressure one way or the other. And we do ask them to come attend special, if there's a special math class or something, we ask them to attend. But what we have found is, if you try to do something like math, it's not too interesting, but if it's something in software programming, that's more interesting to them. That's what we have found.
So you taught programming,
English
math, and English.
Math and English. Yeah. And English and math, I should say, in that order of what they like. They like the programming, they know they need English. Math, not so hard.
Right. And you kind of developed a theory about what and how to teach.
Yeah. So in this, what I've found, this again, everything in my Princeton IIT background kind of tells me that's false, but I know from real world how this works, running this for 5 years. Now there are 100 employees who have come from this program. So we have 100 people who work in this company who came through this, who have nothing more than high school plus whatever that we have taught them in this. And what I have found is that you got to focus on very practical, hands-on learning. This is an engineering discipline. The whole point is to create stuff, make stuff, the makers, and we have to teach them how to do that. And what that does is boost self-esteem. And particularly when someone comes from a background where they didn't have, they didn't see a lot of role models of very successful people, it's highly critical that they develop that self-esteem. And that's why first thing we teach them is how to do. And also crucially, how to make a living.
Yes.
So, and once they get these, then we can actually get into the more abstract stuff. At that point, they will have a motivation. They will also know why some of the abstraction might be important for their future. But what I find in college education today, and this is true particularly in the US, it's actually less so in India where there's a different problem. Here, I believe if you look at all the top schools here, engineering programs have become very math heavy. And that just simply reflects where the professors are coming from, what they like to teach, and what brings them prestige. If you write a paper in most of these disciplines without a heavy math, you would be dismissed as you're not that good. You can't hack it.
Right.
So that's
so the academic world is really the driver of the math curriculum, not necessarily the world where the person's going to work.
I mean, I can tell you we have 1,000 engineers. We have been in business for 15 years now. When was the last time anyone in our company used calculus? Can't recall. I mean, basic stuff. Right. What we need is, all the math I really need at work is like the 10th grade level. Maybe the high school, that's it. Not much more than that. And you can really go far with it. And on every field, I mean, whether to understand your financial models, you need basic stuff. So, and that's what I think we ought to focus on, and then teach them hands-on skills. How to create cool software, how to design user interfaces, how to design databases.
Right.
That's the
I mean, part of it is they're getting feedback on what they're doing right away.
Exactly.
They know whether they're able to do something.
Yes. So that's the key here. That is what we find that it works. And we have had a very successful program. We have less than 5% dropout rate. And we have, everyone who finishes this, we actually have absorbed them, we have offered them a job. So, and of course, they're free to go elsewhere, but we always offer them a job if they finish. And all of them have taken, and I'm happy to say we have some of the most passionate, dedicated employees from this particular program.
Right. And they're not necessarily being tracked for a low-level job.
No, absolutely not.
Right.
Actually, any job in this company is open to them.
Right.
So.
And I think part of what excited me too is this a realization that these are some of your best employees.
Yes,
Right.
yes. They are some of the most determined. And they're still, of course, the oldest people are only 22-year-old.
Yeah.
So they still have a long path ahead of them.
But they're taking leadership positions.
Yes, there's people who are already starting to have people who work with them who are more junior, who have college degrees.
Right.
So all of
but
them
I
are
think
starting
the
to happen.
thing is, even at that age, they want to see results.
Yes.
They want to produce and see that they can make progress.
And the key is, now they are making a living, they are helpful, they are actually supporting their families.
Right.
And that's a big thrill for them.
Right.
That they're able to do that.
Right.
So.
Now, you mentioned that you actually brought a couple students from San Jose over to India to
do this. Yeah,
to do
I
this program.
extended the same program. Actually, I had two students that I know through my, someone who was a nanny for my kid, her grandkid I picked, and then his friend. So we sent them to India for about 7 months, and we trained them, and we brought them back. And the program was successful. But there was a different issue that here we didn't have the right peer group for them. I mean, the young peer group that they needed. In India, we have sufficient numbers. Here, that wasn't there. And then the structure from their families wasn't necessarily there always. Those two things are different about what we did here and in India.
So you made the comment that in India, even the poor families the family structure is intact.
Intact, yes. And that is a problem here. I would say that is a social problem here.
Right.
Right.
But it's, again, it was really this fascinating idea of fast-tracking kids from relatively poor backgrounds without prior experience. You give them a small test to make sure there's some basic skills.
Comprehension.
But other than that, they're not even necessarily showing ability in any area.
In fact, most of the kids who join us, they would never have used a computer.
Right.
They've never used a computer before they joined us.
Right.
So.
Well, thanks a lot. I mean, it's a hopeful thing, and I'm just fascinated what we can learn from this. Could we do some experiments here in different parts of the United States?
I'd love
to. You're really creating a 21st century student here, and we think of all these different. If that's our goal. Someone who can think creatively, create something, program. Hopefully, they'll do better in math and enjoy that. But to embrace the world that we really live in.
And today, if you look at the resources that are available online,
right,
it is any kid can actually put together with some guidance,
right,
a pretty good program,
right,
on his or her own,
right,
and employers should play my particular passion here is employers, companies that can afford it, and tech companies can afford it. They're sitting on huge piles of cash. They should invest in this because it is the seed corn for their next generation of employees, and we have to tap the untapped market. There's 40% of American kids are not going to college.
Right.
So I believe
exactly. I mean, we have these dropout populations.
Yes.
If we could utilize that resource, and if tech companies. I'll put it on here. If you, as a tech company, want to get involved in this, give me a call or you, and I'd like O'Reilly to have a stake in this. So it's I think it's a really good story, maybe a good foundation, something that we could learn from. So thank you very much today.
Thank you, Dale.
Okay.